here's the practice test for you. So the first one, classify a triangle with each set of side lengths as acute, right, or obtuse. So I already put this up here, but again, if you think about it, you're going to take your c squared, all right, and then if it's less, it's acute. If it equals it, it's right, or if it's greater than, it's obtuse. Of course, we're talking about a squared plus b squared. So let's go ahead and do them, not just a couple of them. We'll do all of them. So again, you're just going to take every single one of these and you're going to do a squared plus b squared equals c squared, or c squared. Let's start on that one first. So I'm going to say on the first one, again, c squared. Again, we're going to have something there is equal to a squared plus b squared. Remember, your c squared is always going to be your longest side. So we'll have 12 squared. Again, it's going to be less than, greater than, or equal to. All right. And then it doesn't matter which one's your a or which is your b. So we'll say 5 squared plus 9 squared. And if we work that one out, we get 144 here. We get 25 and 81. So let's see. Again, we're still wondering what's there. So I'll have 144 on this side. On this side, I'll have 106. So 144 is greater than 106. So if we go up here again, since it's greater than, we're going to say that one is obtuse. So we would put this one, 5, 9, and 12, and this one right here is where you would drag and drop it. All right, let's do another one. So let's do the second one again. Just go in order here and see if they're equal, less than, or greater than. So on this one here, I'll have 26 squared. Again, I'm going to put that there. And then I'm going to have 10 squared plus 24 squared. Well, 26 squared is equal to 676. Let's see, 10 squared is 100. 24 squared is 576. So in this case here, we're going to have 676 on this side. We're going to have 676 on this side. So they are going to be equal. And that would make it a right triangle. So then we would drag and drop the 10, 24, and 26 here. Let's see. Our next one, 30 squared. Okay, and again, I'm going to leave that blank, and then we're going to say 25 squared plus 27 squared. 30 squared is 900. And then we're going to have 625 here plus 729. So on this side, we'll get 1354. So 900 is less than that. So we are going to plug that one into here. So it's going to say 25, 27, and 30. And our last one is 50 squared. Okay, again, blank, and 28 squared plus 45 squared. So on this one here, we'll have 2,500. We'll have 784 plus 2025. Hopefully you can see right away that's going to be more. But if not, go ahead and add it all up. So this one here is going to be less than also. So that would make it acute also. So we're going to put this one here also. So we're going to have 28, 45, and 15. All right. Next one, give the value of each trigonometric ratio. So remember, this is, write it down somewhere. Some old hag got a hippie tripping on acid. So the sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So again, if we're going to look at the first one, cosine of A, so we're talking about this one here, okay? We're going to be looking at the opposite side is there, so this is going to be for cosine of A, that's our opposite. Our hypotenuse is always opposite the right angle, and this here would be our adjacent. So on this one here, we're going to say it's the adjacent over the hypotenuse. And if we work that out, we're going to get 24 out of 30. So now the cosine of B, so now that one's going to be different. So if I take the cosine of B, we're talking about this one here. So again, there's my opposite. Here's my hypotenuse always, and here's my adjacent. So on this one here, we're going to have the adjacent over the hypotenuse. And again, on that, we're going to get, let's see, adjacent is 18, and the hypotenuse is 30. If we were doing this on a other test, I would be telling you to reduce the fraction, but since it's just a drag and drop, you don't have to reduce the fraction. Okay, so now again, sine, there's two ways to remember it. We can either go ahead and take our sine of A, and again, A would be the opposite over the hypotenuse. All right, so this one here is going to be the opposite, which is 18 over the hypotenuse, which is 30. So here's our opposite, our adjacent, our hypotenuse. So if we look at that, again, the opposite on that one is 18. The hypotenuse is 30. And again, what I kind of told you earlier is, remember, the sine of one angle is equal to the cosine of the other angle. So if you want to think about it that way, all right, then you can just go ahead and tell me then that the cosine of one angle is the sine of the other angle. So we could just write ahead here as 24 over 30. I could have done that on the first one, but again, you can always check it, right? So here's our angle B. Again, there's my opposite side, which is 24, and there's my hypotenuse, which is 30. Okay, so you might want to remember that as a quick thing to get done quickly. And let's see here. Now let's go ahead and do our tangent of A. So remember, our tangent is going to be our opposite over our adjacent. So if we're looking at A, all right, there's our opposite, there's our adjacent. So we are going to, well, here's our hypotenuse, but we're not going to use it. So here we're going to say it's the opposite over the adjacent. In this case, it's going to be 18 over 24. And then our other one, our tangent of B, is going to be, let's go ahead and get another color. Let's go orange this time. So our B is here. Oops, I don't know what that happened there. So there's our B, there's our opposite, and there's our adjacent. So in this case here, adjacent, that would make this our hypotenuse. So on this one here, we'll have 24 over 18. Okay. So on the next one here, you would do the same kind of thing. I'm just going to go ahead and write them down for you since we already did it with the last one. So on this one here, again, and again, you can always try, but you should have on this one here, 36 over 39. And here you'll have 15 over 39. Remember, the sine of one is the cosine of the other, so this would be 15 over 39 also. And this would be 36 over 39. And then our tangents, the first one would be 15 over 36. And our second one would be 35 over 15. All right. So problem number 4, you are planting a garden in the shape of an equilateral triangle as shown in the diagram. You want to know the area of the triangle to determine how much topsoil you need. So substitute the values of B and H in the formula 1/2 times B times H for the area of the garden. So remember, when we're talking about something like that, all right, our base is where the right triangle, where the triangle has a right angle, and then our height would be here. All right. So now there's 2 ways to do it, ladies and gentlemen. We could go ahead and just use the sine, cosine, and tangent, or we could remember this is a special right triangle here because it's a 30, 60, 90 triangle. And if that's the case, then I would write here, and I'll do it in a different color since I have a blue there. But we would write this as A, 2A, and A times the square root of 3. So if we look at it, remember, this right here is going to be 1, which it should make sense because 2 times what equals 2. So A is equal to 1, so our H is equal to 1 times the square root of 3, or just the square root of 3. So on this one here, we're going to say it's 1/2 times 2 times the square root of 3. Okay? So don't plug in this one here. That's a distractor term there. They're trying to get you to do that one. Don't worry about that one. Okay? It's 2 times. So you're going to use this one here and then this one here. Okay? All right. So you hike 250 meters up a steep hill, has a 37-degree angle of elevation as shown in the diagram. All right. Give each side an angle measure rounded to the nearest whole number. All right. So again, you have to kind of look and see what you have there, ladies and gentlemen. So we have this angle here. All right. And it looks like we have our hypotenuse. All right. So remember, we have to have at least one side and the angle, or 2 sides. So on this one here, again, I can always state that the side opposite the angle is always the opposite one, and then this here one would be the adjacent. So if we remember that, we can say that again, SOHCAHTOA. So we're going to say sine of 37 is equal to the opposite, which is A, over the hypotenuse, which is 205. All right, so again, I would multiply both sides by 205 to get A by itself. So when you plug in A is equal to 205 sine of 37, you will get 123. So this one here would be 123 meters. Do the same thing for the B. So when we go to B here, again, we're going to say we have this 37 degrees here. We're going to have the B, which is the A, the adjacent side, over the hypotenuse. Which one uses the adjacent and the hypotenuse? You would say cosine. So it would tell me cosine of 37 is equal to B over 205. So same thing. And when we plug that one into our calculator, we'll get that B is equal to 164 meters. And then to find the other angle, the measure angle B, remember these two here are complementary. That means that they add up to 90 degrees. So we can say that the measure angle B is equal to 90 degrees minus the 37 degrees, and that will give us 53 degrees. All right. So now, again, the same kind of thing here. So since we've done 2 in a row, so I don't have to make this video be very long, I'll just tell you the answers on this same one here. We'll do the same exact thing, ladies and gentlemen. So on this one here, if you did the first one, you'd have 220 sine of 43, or 150 meters. We'd have 220 cosine of 43 degrees, which would give us 161 meters. And then the measure of the angle is 90 minus 43, which would give us 47 degrees. Okay. Pretty straightforward, I hope. Right now, remember, we're always talking about stuff like that. So find the value of x and round your answer to the nearest tenth. So again, think about SOHCAHTOA. If I go here, I'm going to get this here is my opposite. Here's my hypotenuse. Here is my adjacent. So what am I going to use? On this one here, I'm going to use tangent, because here's an x, and there's my 8. So we're going to say that the tangent of 72 degrees is equal to 8x over 8, excuse me. So again, same kind of thing here. So we'll get x is equal to 8 tangent of 72 degrees. And remember, put your calculator in degrees, and I'll remind you on the test day also. So if we do that, we'll find that x is approximately equal to 24.6. So watch what it says. Here it said to the nearest tenth. Up here on these ones here, it said to the nearest whole number. So watch stuff like that, okay? Make sure you put it in right, or they're going to mark it wrong. Okay? So same thing on this one, kind of like the other one, except notice that we're going to have to do something slightly different. Here's my opposite side. Here's my adjacent side in this case. And here's my hypotenuse. So again, the two that are marked are my opposite and my adjacent, which would tell me I would use the tangent. So let's say the tangent of 68 degrees is equal to 24 over x. Now remember, I said if x is on the bottom, ladies and gentlemen, the easiest way to solve for it, because again, you'd be taking the cross products, but just think, you are going to switch those two. On the top one, notice it was on the x was on top. On this one here, it's on the bottom. So we're just going to switch the two. And when I work that out, I'll get approximately 9.7. Right? Okay, number 9. A 10-foot ladder leans against the side of a house with its base 2.2 feet from the house. Use the Pythagorean theorem to approximate how high the ladder reaches up the side of the house. Round your answer to the nearest hundredth. So what they're saying here, here's the side of our house, right? Here is my ladder that is leaning up against the house, right? And again, my drawing's not perfect. It actually almost looks like it's a square. But that's 2.2. My ladder is 10 feet long, so we need to find this height here, all right? So, and they're telling us to use the Pythagorean theorem. So remember, a squared plus b squared equals c squared, or c squared in this case would be our hypotenuse, right? And this here would be one of ours. So we could say then that we could call this x, and this here would be our other one. So we could say a squared plus b squared is equal to c squared, or we can say that 4.84 plus x squared is equal to 100. I'm going to get x squared by itself. I will say x squared is equal to 100 minus 4.84. Again, so x squared is equal to 95.16. Again, to undo a square, I'm going to take the square root of it. And when I round that to the nearest hundredth, that's 2 decimal places, I'll get that x is approximately equal to 9.75. Okay. All right. Let A, B, and C be acute angles. Use a calculator to approximate the measures of angle A, angle B, and angle C to the nearest tenth of a degree. So it's saying that the cosine of A is equal to 0.31. So remember, when I take that, to find the angle of it, I'm going to take the inverse. So the measure of angle A is equal to the inverse. So I'm going to say cosine to the -1 of 0.31. I plug that in. They said to the nearest tenth. That'll give me 71.9. If I take B then, the measure of angle B is equal to sine to the -1 of 0.89. And that will be 62.9 degrees. And then the last one is tangent, so the measure of angle C is equal to the inverse tangent of 0.52. And that will equal 27.5 degrees. Okay, so same thing with number 11, it's the same thing. We're doing the same thing as we just did above. So I'm just going to throw down the answers here for you. So 41.3, because that's the inverse tangent. This one here is the inverse cosine, so that would be 50.2. And then the last one is the inverse sine, so we would get 14.5. Okay. Let's see, number 12, solve the right triangle, round decimal answers to the nearest tenth. So again, let's see here. First thing we did is, remember we talked about using the Pythagorean theorem, so I can say that 11 squared plus b squared is equal to 13 squared. So then I would take, and I'd get 121 plus b squared is equal to 169. So if I subtract the 121, I'll get that b squared is equal to 48. And then I'll get b is equal to the square root of 48, which is approximately 6.9. Okay. Now, remember, when we're talking about the angles here, and let me use a different color again. So if I'm talking about this angle here, and remember, what I suggested is that you use the ones that are known in case you made a mistake. So if we use this angle right here, we know we're going to have the opposite, and we're going to have the hypotenuse, because here's the adjacent. So I can say that the sine of A is equal to the opposite, which is 11, over the hypotenuse, which is equal to 13. So our A then would be the inverse sine of 11/13. And if we work that one out, we'll get 57.8 degrees. And then the easiest thing to do on the other one, you could always use the cosine of it, but remember that we can always say that the two angles here add up to 90 degrees. So the measure angle B would equal to 90 minus 57.8, which will equal 32.2. I forgot to underline this one. All right. So shall I do the same thing here? All right. Well, on this one, since it is a little more involved, I'll go ahead and finish it for you real quick. So on this one here, again, we'll have 6 squared plus b squared, notice how my b has a straighter line than my 6, is equal to 14 squared. So then I can say that 36 plus b squared is equal to 196. I'll get that b squared is equal to 160 because I'm going to subtract that 36. And if I plug that in, well, what is that? That's going to be the square root of 160. And that will give us 12.6. Right? Then for the measure of angle A, again, look at what we have this time. Again, here's our opposite. Here's our adjacent. Here's our hypotenuse. So on that one there, I would use sine again. So sine of A is equal to the opposite, which is 6, over the hypotenuse, which is 14. So we can say that the measure of angle A is equal to the inverse sine of 6 over 14. And we work that one out, we'll get approximately 25.4 degrees. And then again, the measure of angle B, we can say is 90 minus 25.4 degrees, which will give us 64.6 degrees. And then our last one here is just a little tricky, that's all. But you just have to add something here. So in this one here, so it's saying your math teacher asks you to calculate the height of the goalpost on the football field. You and a partner gather the measurements shown. So you have 72 degrees. You have from you to the goalpost is 12 feet. And it wants you to find the top of the goalpost. So that's up here, all right? So first thing you know is you have 12 feet here, okay? This is what you're trying to find, is this height here. That's part of it. This is a tricky question. It's not too bad though, all right? So again, if we look at what we have, here's our 72 degrees. That's our angle of elevation, correct? And if we look, we're going to always draw through to the opposite side. So we have H there, and we have our adjacent side. So which one uses the opposite and the adjacent? You would say that it's the tangent of 72. And again, that would be H over 12. So again, if I multiply both sides by 12, I would have that H is equal to 12 tangent of 72 degrees. And if you work that out to the nearest tenth, you'll get 36.9 feet. But that is from here to here is 36.9 feet. We need to know how tall it is from here to the ground. So let's go ahead and look at a different color for that. So we're looking at this whole thing here. All right. So if you think about it, you have your 36.9 plus how tall you are, which is 5.5. And when we work that out, ladies and gentlemen, you should get 42.4 feet. So that is your answer. All right. So what they're just kind of saying here is, you have to add that 5.5 feet for how tall you are. So good luck on your test tomorrow. Well, I mean, not tomorrow, but on Wednesday. So good luck, people. Thank you.